Okay, so in today's our tutorial, we're going to talk about the norm functions. There's a family of functions. So what I'm going to do is I'm going to type in R norm. That's the function we're going to be using the most with a question mark in front because that question mark tells R to tell me everything it knows about this function. So here's what I get. I get that this is a function about the normal distributions. That norm should have been a clue. And there's four different norm functions. So the first is dnorm, this density function, and it gives the height of a probability density function at x. So let me type that in. So dnorm gives the height of density of the probability density function at x, right? That's a good thing for us to know. P-norm, right? Our second one, P-norm, gives the probability, i.e. this is like your standard normal distribution. What do I mean by that? Okay, so let's look at P-norm. P-norm has a mean of 0 and a standard deviation of 1 as its standard go-to. I could change that, but I'm not going to. And we know that in a normal distribution, our mean divides our data set in half. So if I did p-norm of 0, when my mean is 0, and my standard deviation is 1, SD stands for standard deviation, I should get out the probability of 1/2 because I've got 1/2 of the data. And wouldn't you look at that, I get out the probability of 1/2. Q-norm, essentially what it does is it undoes p-norm. So q-norm, you give it a probability and it gives you the data value. So for example, if I did p-norm of 1.5, so what's the area below 1.5 when our mean is 0? And again, you don't have to type in mean equals 0 or standard deviation equals 0 as those are the presets, but I just wanted you to be aware. That's going to give me a Q value, not a Q value. That's going to give me a probability value of, there we go, of 0.933. And that makes sense. A lot of our data should be 1.5 standard deviations above the mean and below. So if I was to say type Q norm of 0.933192, so what P norm spit out with the same mean and the same standard deviation, I should get a value very close to 1.5. And there you go, I got 1.5. So that's P norm. What we're going to be using the most for this tutorial is R norm. And what R norm does is R norm randomly generates in values of x that fit a given normal distribution. Okay, so yeah, where do I want to go with this? So let's maybe talk about p-norm a little bit. So let's talk about the 68, 95, 99.7 rule. Okay, 68, 95, 99.7 rule. And the 68, 95, 99.7 rule is this, that under a normal distribution, right, I'm going to have 68% of the data within the first standard deviation, 95% of the data within the second standard deviation, and 99.7% of data within the third standard deviation. So if I wanted to know the probability of data lying within my first two standard deviations, because my standard deviation is 1 up here in this example, let's just copy it because copy makes it easy. I could take the probability of me being 1 above the standard deviation minus the probability of being one below the standard deviation, and I should get something really close to 68%, right? The same thing would work for 2 standard deviations above the mean. Again, I'm putting in 2 because my standard deviation is 1, so 2 standard deviations above the mean would be 2, and then 2 below would be -2, right? And I get something really close to 95, right? But what I want to talk about mostly is this R norm function, and we're going to randomly generate and build some normal distributions, which I think is very exciting. So let's go ahead and define our set of variables I'm going to produce. So I'm going to produce x1, and I'm going to have x1 be a data set with 10 data values. I could change the mean, so let's have a mean of 5 and a standard deviation of 2, so why not? So if I run this, this is x1. There's an error. Oh, I forgot an equal sign. That's okay, I can put that in there. I don't know why it's printing all that other stuff. So if I type x1, I should get 10 values that are normally distributed with a mean of 5 and a standard deviation of 2. And if I wanted to, I could make a histogram of this and just see what this looks like. But I might have to actually type it correctly first. All right, so here's a histogram. See, it's kind of normally distributed, but this is a really small data set, right? Typically, with a normal distribution, we definitely want a data set larger than 30, right? Think about students T and how it relates to that. Sneak preview for what's coming. So let's make a bigger data set. What if I make a data set with 100 values? Okay, so let's make a histogram of that. All right, so here's our histogram of x2. See, it's a little bit closer to a normal distribution, but not quite, right? 2 things I do want to point out. I made a mistake here. I wanted this to have the same mean and standard deviation as our first set. So I'm going to change that. That means I'm going to have to run this again and then graph my histogram again. So every time I run this code right here where I define x2, you can expect the data set's going to change, so my histogram's going to change. See there? Do it a couple more times. Oh wow, that's a weird one. Let's keep that one. Again, still not perfectly normal. I want a bigger data set. So let's let x3 be our norm 1000. So I'm randomly generating 1000 pieces of data with a mean of 5 and a standard deviation of 2. Notice it's popping up like it's standards settings, so that's cool too. So here I've got x3. Let's go ahead and plot that. Oh, I think I got an email. So I'm going to plot x3. And, whoop, I didn't mean to plot, right? Because that creates a scatter plot of each piece. So this is like my first piece of data and its value versus my 1000th piece of data and its value. This made a scatter plot. I didn't want to do that. I wanted to make a histogram. So histogram organizes my data into bins. That fits a pretty darn normal distribution, right? So right now this is a frequency distribution. So I have the data value, so something like between 4 and 5 occurs about 200 times based on our graph. Something between 5 and 6 would occur about maybe 175, 180 times, right? This is our frequency distribution. I want to change this to a probability distribution. So if I type in (hist), right? There are 2 ways to do this. I could do frequency equals false or probability equals true. Both of them will do the exact same thing, and I'll show you how. So if I make another histogram of x3, okay, I'm going to, beautiful, but this time I'm going to make it, instead of frequency, it's going to become a probability function or a density function. So I could do probability equals true, and that true has to be in all caps. Don't forget that. So see, now the graph didn't change, which makes sense because frequency and density distributions would have the same shape, right? But now I've got a density. Let me show you how that would also work if I did frequency equals false. So I could do a histogram of x3, lowercase x3, frequency equals false. So I'm not making a frequency distribution. You get the exact same graph. I tend to go probability equals true so I know what I'm working with, but this graph would also work out as well. I'm going to comment that out with a hashtag or an octothorpe. What I want to do is I want to put a curve along our histogram. So what I'm going to do is I'm going to type the word curve, and this is when I'm going to use dnorm. So dnorm, right? That gives me the height of the probability density function at x. I'm the typo queen. Dnorm of our x with a mean of 0 and, sorry, not 0. Our mean is 5 and our standard deviation is 2, right? So it's going to give me the density function for that. I'm going to have to add that to my graph. And let's make it a color. I'm feeling like red would be a good color. And there you have it. When I hit enter and run it, it fits a normal curve to my graph. So why don't we try and do this with some real data? So for example, you know I am a sucker for the IRIS data set. If you don't know about it, then you haven't watched a video on this channel before. So I've got question mark IRIS, right? IRIS has 4 measurements, one of which is sepal length. So if I found the mean of our sepal length, and I find the standard deviation of our sepal length, that means I could go ahead and plot these. So first I'm going to make a histogram, and I could make this a lot prettier. I could add in a title. So I'm going to do IRIS sepal length. I want my probability to be true. That's going to make a density function so that I can add a curve. And then I would do curve dnorm of x. Then I need our mean, which in this case I can either type 5.843333, or I could put this in there, which is kind of cool. So I didn't even read to really calculate those in the first place. And I can do this standard deviation of sepal length. And then I do, let me make sure I have enough parentheses. I do. Then I do add as true. And I make it a color. I think the default color is black, but let's make it a color. Let's make it yellow. And again, I could have, you know, staggered this line and it would still work. So let's go ahead and run this. Something went wrong. What is wrong? IRIS sepal length probability equals true. Maybe I need a lowercase probability. There we go. And once it's a lowercase probability, then it's not a frequency distribution, so I can add my line. And there you go. It's very, very faint. Maybe I should switch that to a better color so we can all see it. There we go. And there is a normal curve fit to our data set.